This is Writing and Solving Systems of Equations from Word Problems, Part 1. In this video, we're going to look at 3 past region questions related to the topic of writing and solving systems of equations from word problems so that we can learn how to do this. The first question we're going to look at is question number 5 from the June 2016 Algebra 1 region. The Celluloid Cinema sold 150 tickets to a movie. Some of these were child tickets and the rest were adult tickets. A child ticket cost $7.75 and an adult ticket cost $10.25. If the cinema sold $14.70 worth of tickets, which system of equations could be used to determine how many adult tickets A and how many child tickets C were sold? So let's write out what we know. We know that A, they tell us, is the number of adult tickets. And we know that C is the number of child tickets. And we know that the total number of tickets sold was 150. So we could use this information to write an equation. Know that the number of adult tickets, A, plus the number of child tickets, C, is going to be equal to the total number of tickets, which is 150. That's one equation. Let's write another equation. We know that each child ticket costs $7.75. And we know that each adult ticket costs $10.25. And we know that the total amount the total dollar amount of tickets that the cinema sold was $1,470. So we could use this to write another equation. 7.75 times the number of child tickets plus 10.25 times the number of adult tickets is equal to 1470. What this equation is saying is that for every child ticket, we get another 775. For every adult ticket, we get another 1025. And the total that we earn from all our child tickets and all our adult tickets is 1470. So which choice do these equations match? It's choice 1, A plus C is equal to 150. And we could rewrite our other equation as 10.25A plus 7.75C is equal to 1470. The order doesn't matter in addition. And that is choice 1. Let's look at another question. This is question number 19 from the August 2014 Algebra 1 Regent. During the 2010 season, football player McGee's earnings, M, were $0.005 million more than those of his teammate Fitzpatrick's earnings, F. The two players earned a total of $3.95 million. Which system of equations could be used to determine the amount each player earned in millions of dollars? Let's write out what we know. We know that M is McGee's earning. And we know that F is Fitzpatrick's earnings. And we also know that the two players together earned a total of $3.95 million. Therefore, M, McGee's earnings, and F, Fitzpatrick's earnings together is equal to $3.95 million. So this is going to be one of our equations. Let's write another equation. During the 2010 season, football player McGee's earnings, M, were $0.005 million more than those of his teammate Fitzpatrick's. Therefore, McGee's earnings, M, are equal to whatever Fitzpatrick gets plus another $0.005. This is going to be our other equation. And the correct answer to the question is the choice with these two equations, which is choice 4. Let's look at one more question. This is question number 6 from the June 2015 Algebra 1 Regent. Mo's farm stand sold a total of 165 pounds of apples and peaches. She sold apples for $1.75 per pound and peaches for $2.50 per pound. If she made $337.50, how many pounds of peaches did she sell? So we need to write some system of equations relating the number of peaches and the cost of peaches so we could solve for the number of peaches. So let's use A to represent the number of pounds of apples, and we'll use P to represent the number of pounds of peaches. And 165, we know, is the total number of pounds of apples and peaches. So we could use this information to write an equation. We know that A, the number of pounds of apples, plus P, the number of pounds of peaches, is going to be 165. So this is one equation. And now we have to write another equation. We know that apples are $1.75 each, and we know that peaches are $2.50 each. And the total amount that she earned was $337.50. So we could use this to write an equation. 1.75 for each apple plus 2.50 for each peach is equal to 337.50. This is our other equation. Now we have two equations, and we need to solve this for p. These two equations, it's a system of equations, and we need to solve for p. So if we rearrange a plus p is equal to 165, if we subtract p from both sides, minus p and minus p, we're left with a is equal to 165 minus p, and we could use substitution. We're going to substitute this a over here for 165 minus p, and we're allowed to do that because we know that a is equal to 165 minus p. Once we do that, we'll have an equation with just one variable, with just the variable p, and p represents the number of peaches, which is what we're solving for in this question. Let's do that. 1.75 times a we know is 165 minus p, plus 2.50p is equal to 337.50. And now we need to solve this. So we're going to distribute 1.75 over the 165 and over the negative p. 1.75 times 165 is 288.75. 175 times negative p is negative 1.75p plus 2.50p is equal to 337.50. Let's combine the like terms. 288.75 negative 1.75p plus 2.50p is 0.75p. This is equal to 337.50 minus 288.75 minus 288.75. 0.75p is equal to 337.50 minus 288.75 is 48.75. Let's move this to the next column. 0.75p is equal to 48.75. Divide by 0.75, divide by 0.75. P is equal to 65. That means that she sold a total of 65 peaches. Let's go back to the answer choices, and that is choice 3.